value, we just broke this down into something we can work with. We want this inside 1 to be 2 or 4. Okay? So now, I to the 4th is what? 1. Just like I squared is negative 1, I to the 4th is positive 1. So we have a 1 raised to the 5th power. I don't have to put those parentheses. I'm just going to be clear, just to be consistent and clear. So I to the 4th became 1. And 1 raised to the 5th power is 1. We don't care whether that, once we know we can put a 4 in here, it doesn't even matter what that exponent is.
So if your exponent is divisible by 4, then the answer is 1.
Yeah. And once you see that pattern, yeah. If it's an even number, it's either going to be 1 or negative 1. And if it's actually not only even, but it's also divisible by 4, it's going to be the positive 1. Exactly. So if you did I to the 34th, okay, is that even? So without, and as long as there's not a coefficient in front of it, the answer is going to be 1 or negative 1. So we want I to the something, 2 or 4. Yeah, 4 would be preferable, but that's not divisible by 4. So we have to use a 2. And so we do need this outside exponent, definitely. Here, it didn't really matter what that was. What is it here? 17, yeah. And so I squared is raised to the 17th power. Now, because we had to use I squared, that means our base is negative 1, which means whether our answer is positive 1 or negative 1 depends on that. Huh? Yeah, it has to be negative. It's negative 1, because with an odd exponent, we'll have pairs of negatives that cancel out to positive, but we'll have an extra negative. So as you look at these patterns, as you practice these, if your exponent is even and is divisible by 4, your answer is positive 1. Okay. But if your exponent is, let's do, for example, I to the, let's see. Hold on. Now, I was about to say, is there going to be an even exponent? Yeah. Not off the top of my head, so, okay. But that's the idea. If you have a 4, no worries. Yeah, complete your reverse product rule there. Reverse power rule, sorry. But regardless, you've got a 1 raised to any power is positive 1. Even exponent, no problem. It can be a 2 or 4, but if it can't be a 4, you use a 2. Base of negative 1, put that outside exponent. And that whether that is even or odd exponent on the outside will tell you positive 1 or negative 1. Huh? But either way, even exponents, you're going to get a real number answer, 1 or negative 1, unless there's another coefficient in front, and then you just multiply that coefficient times that. Is that okay? So let's look at the case, what if we have an odd exponent? Let's say if we had I to the 19th. Okay. So an odd exponent is going to be a real answer or an I? I. Any odd exponents are either going to be I or negative I. So the first thing we want to do is first we're going to reverse our product rule here, okay? Because we want this to be even. We can't break it up into a 2 or 4 until it's even. So first let's use our reverse product rule and say this is I to the 1 times I to the 18. Yeah. Okay. See, if you've got an odd number, all you have to do is remove 1 and you're going to have an even number. Okay? So basically you're pulling an I out, and it's true that 1 plus 18 is 19. You didn't change the value, but now you have your extra I, and this I to the 18th is going to decide whether it's a positive I or a negative I. Okay? So this is equal to I to the 1 is just I, times I raised to something to something. Now 18, is that divisible by 4? No. It is even, but not divisible by 4. So what do we put here?
2.
A 2. And on the outside we put a 9. So this is equal to I times negative 1 to the 9th power. I times negative, yeah, because it's negative 1 to an odd exponent, so it's going to still be negative 1, which means our answer is,
Negative 1.
yeah, I times negative 1 makes it negative I. I to the 25th. odd exponent, pull out an I, so you have an even exponent. You know because it's an odd exponent, you're going to have either an I or a negative I. You just got to figure out which one it is. So you get an I times I to the 24th. This I to the 24th will determine whether this I stays positive or becomes negative. Divisible by 4? Yeah. And so the outside would be 6. But still, I mean, finish your power rule there. But still, once that's I to the 4th, once you know that's divisible by 4, the answer is going to be
Positive.
right. So it's still a non-real answer, but it's a positive I instead of a negative I. So there's already rules you know about exponents. Power, product and power rule, and now product and power rule in reverse, like we worked with radicals. Is that okay? Questions? This finishes up that 11-7 homework. There's one last homework for this unit, 12-1 and 12-2 all together, so we're going to start on chapter 12 now. Okay. We'll complete about half of it and finish the rest on Tuesday. Again, as I was urging at the beginning, I know a few more people came in. If you came in and you haven't gotten your test back, just make sure and remind me at the end of class. We do have a lot of new material still to do on Tuesday, so don't take that Thanksgiving holiday early, okay? Do your best to be in class. You will regret missing that material before because the test we're taking is immediately after Thanksgiving, as soon as you come back on Thanksgiving. So it'd be very difficult to miss the next class, Tuesday, and do well on the test. Okay, so let's move into chapter 12. So specifically 12.1. But actually, before we do that, okay, so 12.1 is basically, and I'll explain what this means, and this is other, 12 in general is other quadratic methods. Okay. So we're going to come back to that in just a sec, but let's look at the quadratic method we already know. Now, when I did this in my 8 a.m. class, I got a lot of blank looks, a lot of deer in the headlights. Okay. If that's your response to this, pay attention to that response. Okay. This is a skill that we've already covered. It will be on the final, and not only that, but it's foundational to college algebra. You've got to be comfortable with what we're about to do. Okay. So, we're going to learn some other quadratic methods, meaning some other ways to solve quadratic equations that don't involve the way we've already been solving them. Okay. The way we've already been solving them is from 9.4, okay, which is solving quadratic and also cubic, second degree or third degree equations. I'll abbreviate there. And the method we used was by factoring. Okay. So of course if we have a linear, remember it's quadratic or cubic or linear. Linear, quadratic, cubic just means what degree it is. Linear is degree 1, quadratic's degree 2, cubic is degree 3. A linear equation, you just solve for x. Use your general strategy, your addition and multiplication properties. Add, subtract the both things, the same thing to both sides. Divide away your coefficient. You get x equals c. You get x equals a number. Okay? A linear equation has how many solutions? 1. It's first degree, linear, 1 solution. It makes a line, the related thing makes a line on a graph, 1 x-intercept. A quadratic equation is degree 2. How many solutions? And how many solutions for cubic? Degree 3. 3. The degree tells you how many solutions. Now, a linear equation, we just use our general strategy. Quadratic and cubic, we have to have another method. We can't just solve for x because our x has an exponent on it. Okay? So we'd end up with x squared equals something, or x cubed equals something. That's not going to get us anywhere. Okay? Well, it can. We're going to show some methods where it can. But what we started with is the idea that if we have a higher degree, we can't just use our general strategy. We have to factor. Okay? And when you factor, you are going to get linear factors, and each factor will give you a solution. So you remember your basic setup for solving by factoring is, 1, what do you have to do? You're going to factor. What's the first thing you have to do?
Bring down.
You haven't before you even start factoring. Before you even start factoring even a GCF.
See if it's linear or...
Yeah, what form? Standard form. You can't start factoring until everyone's at the party, right? So the factoring method requires everybody be in the same room. Okay? So first you have to have standard form. If it's not already in standard form, then set it in standard form, which means you set it equal to 0. Okay? Now our other methods that we're going to learn do not require standard form. There's 3 more methods we're going to learn. One of them requires standard form and the other 2 don't. Okay? So understand, we're going to have 4 different methods before you leave for Thanksgiving. Okay? So you've got one method already, and each method requires a different setup. Okay? So this one, standard form, once it's in standard form, then you can factor completely, which, yes, you start with a GCF, and then you go from there. Whatever factoring method is required. And you're going to end up with linear factors. If you don't end up with linear factors, and you can't end up with linear factors, then you can't solve this by factoring. All the ones I gave you, you could solve by factoring because you were able to factor them completely. You know you're not done factoring until everything is linear, or at least until, if it's not linear, you've tried and you can't go further, it's prime. Okay? And we did some factoring like that, but when I gave you equations to solve by factoring, I told you everything will be factorable all the way down to linear factors. Okay? Because if it's not, you have to use a different method. So you factor completely down to linear factors. Okay? And then once you have linear factors, you set each factor equal to 0, because that is using our 0 factor property. Okay? And each linear factor set equal to 0 gives you a little linear equation, and each one's going to give you a solution. So if it's quadratic, you'll get 2 linear factors. Each one will give you a solution to get 2 solutions. Cubic will give you 3 linear factors, and you set each of those 3 things equal to 0. So with that in mind, solve these 2 equations. Both of these can be factored completely, therefore they can be solved by factoring. And if you're looking at that and you're going, what? 9.4. That homework is closed, but you can still access it through View My Grades. That 9.4 homework is a great selection of the various types of quadratic and cubic equations you can solve by factoring. Go back and practice those. Through View My Grades, you'll get the same homework problems with different numbers. Okay? Look back in that section of the textbook. Reach out to me for help or tutoring or each other. You have to be able to do this. Okay? Already in standard form. No GCF. Okay? Count 1, 2, 3. It's a trinomial. It's a quadratic trinomial, so I can use my ACB. A equal 1 or A not equal to 1? A equal 1. So ACB and I'm done. Okay? If A was not equal to 1, I'd have to ACB and then group. Okay? So I have to know how to factor. So naked x squared, I got naked x's, mixed sign pattern. I can do my ACB chart if I need to, no problem there. AC is negative 15, B is positive 2. And because A equal 1, once I find my magic pair of numbers, I'm done. That would be I know I got 1 positive, 1 negative, so it would be positive 5, negative 3. Yes. Don't forget, it's still equal to 0. You're not just factoring, you are solving an equation. 0 factor property means in order for this to be true, then either this factor is equal to 0 or this factor is equal to 0. As long as I didn't make careless, I want to go back and check my work to make sure I didn't make careless mistakes. But I don't have to worry about extraneous solutions. If I did all the math right, these are good solutions. It's not like when you use the when you do radical equations or rational equations, you have to check for extraneous or bad solutions. I'm expecting, this is a cubic, I'm expecting 3 linear factors. There was a GCF, once I put it in standard form, there's a GCF. Now if that GCF were just a 2, that is a factor, but is that a linear factor? Does it have an x? No. Linear means it has an x with an exponent of 1. Okay? If it were just a 2, it would be a numerical factor, which is great. It's a factor, you have to pull it out, but will it give you a solution?
Say that again.
If you had just a numerical factor, let's say all you could pull out was a 2. That's a factor, you have to pull it out to finish factoring, but will it give you a solution? No, it's just a constant, it's just a numerical factor. You want to factor to linear factors. You have to pull out any numerical factors, but if there were not an x, it's not linear, it's a constant. Okay? So yeah, you got to pull it out, but the only ones that count, you're looking for 3 linear factors, you're looking for 3 factors that include x's. Yeah, you got to pull out the 2, but this one also has an x in common. There's one linear factor, because it has an x with an exponent of 1. And then you say, I'm not done here. 2 more can happen. Ooh, difference of squares, conjugates. 2x equals 0. Now, like I said, if this were just a 2, not a 2x, 2 equals 0. Does that make any sense? No. So, I mean, yeah, it's a factor. You can set it equal to 0, and then you say, well, that's nonsense, so you throw it out anyway. Answer's not 2. Okay? Now here, our x equals 0. It doesn't matter if the coefficient, anything 0 divided by anything is 0. Now, all of these answers, here, and any other ones that you did in 9.4, all of these answers are real numbers. Okay. There's no i's. Okay. Are there any radical signs? No. So they're not only real, but they are specifically rational. Okay. Because remember, when we look at our chart from last time, okay, real numbers don't have an I. Non-real have I's. Real numbers don't have I's, but real numbers can either be rational or irrational. Okay? Irrational numbers include all the square roots of non-perfect squares. Okay? So if you've got answers that have no I's and no radical signs, then you have real, rational answers. Factoring, if you can solve by factoring, you will get real rational answers. If you end up solving by a different method but you get real rational answers, then that means you could have factored. Okay? That's often the best choice, and you should have factored, but often it's easier to do a different method, and that was fine. The more methods you know, the more you will learn to, with practice, make the best, most efficient decision about which method to use. Okay, all right with that? Now let's get to 12.1, other quadratic methods. Other quadratic methods, there's 3 other methods, basic methods that we use, and we use them whenever we can't factor. Or if we can factor, but the factoring is ugly. Okay? So the other methods we can use even if we could factor, but a lot of times factoring is the most efficient choice. That is it's already in standard form and it's super easy to factor. So why make another mess of it? Okay. So let's look at x squared equals 9. A very basic quadratic equation. It's quadratic and it's an equation. Now, by the method you know so far, by factoring, what's the first thing you would do? Yeah, you put it in standard form. Then you would factor completely. It's a basic difference of squares. How many solutions are you going to get? 2. 2 linear factors. Each linear factor gives you a solution. Right. Now, what about this? Go ahead and put that in standard form. Now factor completely. Yeah. Right. Is this, it's a binomial, no GCF, so is it a difference of squares? It's not. Perfect square there, but not there. Okay. So, we can't factor it. Okay. So, we can't solve it by factoring. Okay. All right, so here we could solve it by factoring, here we can't. Let's look at a different method then. Let's take the same x squared minus 9 though. X squared equals 9. Okay. And don't put it in standard form now. One thing I see some people start to do, they start to get an instinct for this, and it wasn't really time yet, but now we're really going to formalize it. So if your instinct was to do this before, yes, but now pay really close attention to the real specific rules that are needed. Before we do anything else with this, let's think logically. If we want to find x, then that means we need a value, some number, which when it is squared equals 9. So what's squared would equal 9? 3. But wait a second, this is quadratic. We're expecting 2 solutions. Is there another number besides 3 that you can square and get 9? Negative 3. Okay. 3 squared is 9, and negative 3, in parentheses, negative 3 times negative 3 is also positive 9. Okay. 2 possible solutions. The fact that it's quadratic tells us that. Okay. And the nature of a square. Now, when we were going from radicals and and square rooting, we always assumed the principal square root, and we only used the negative square root if we were told to. But now we're going in the other direction. Now we have to account for the 2 possibilities. Okay? So you are allowed to square root this as long as you do what to the other side? Same thing. That keeps it fair and balanced. But we also know if we just go ahead and do this, and this is x equals 3, we're missing a solution. Okay. We know there's going to be 2 solutions. We know when we square root this, then there's 2 possibilities that could have made that 9, so we have to put up in front a plus minus. So we have to account for both that principal and that negative square root. Because when we're going in reverse, we have to admit, hey, there's 2 possibilities here when we go in reverse. Okay? So now the square root of a square obviously frees the x. And then, yes, now we simplify that radical however we can. If it's a perfect square, good. If it's a partial perfect square, you simplify. All these radical stuff I just gave the test back from. And there was a lot more complex and lots of variables and exponents and messy stuff on that test. But the basic skill of being able to look at a radical and know is it a perfect square, or if it's not, is it a partial perfect square, and being able to simplify it is going to continue. Okay, so that basic understanding. This is a perfect square, so it's just plus or minus 3. Now that means 2 answers. Okay, that is both positive 3 and negative 3. Plus minus means you've got 2 answers. So this means x equals negative 3, but it also equals positive 3. And of course, in set notation, you just put it. Okay. So let's consider that with x squared equals 10. Now, do we have to put this in standard form? No. When we factor, we have to put in standard form. When you use this property, you do not. In fact, you shouldn't have it in standard form. This, you're ready to go. But if you were given it like this, you couldn't do anything until you moved this over to the right. You need an x squared on the left and a number on the right. Okay? So like I said, there's 4 different methods. You've done one method, factoring. We're going to learn 3 new methods. This is our second method. But each method requires different things. Okay, so don't think, oh, I'm solving a quadratic, it must go in standard form. No, it depends on how you're solving it. If you're factoring it, yes, it does. If you're using the square root property, no. Square root on the left, the perfect square, the x squared on the left, and a number on the right. And now you can apply that property.
Can we do that thing that do the times it's, like 2 square root of 2 times square root of 5?
Yes, if that's going to get you somewhere.
But it's not.
Right. And this is actually something I saw a number of people do on the test. I think even with the number 10. Yes, this is not a perfect square, so some people wanted to break it up as 2 times 5. Well, yeah, 2 times 5 is 10. That's mathematically true, but then you'd have square root of 2 times square root of 5. Are either of those perfect squares? So it doesn't get you anywhere. Mathematically, yes, square root of 2 times square root of 5, but it doesn't simplify it. Okay? So this can only be broken up if it's not a perfect square. It can only be broken up if it has a factor pair that includes a perfect square. Okay? If it's not a perfect square, if it is a perfect square, it'll be totally released. If it's a partial perfect square, it'll have a perfect square factor that can be rooted and released, and another factor that is trapped, the leftover bit. Okay? So that's as simple as it gets, because it's not a perfect square, and it also doesn't have a perfect square factor. Good question. I meant to point that out, so I'm glad that came up. You want to simplify this radical as far as it can be simplified. Sometimes it's as far as it already is. This makes that an x, and this is plus or minus radical 10. Therefore, our solution is negative square root of 10 and, comma, positive square root of 10. Now this has real, rational solutions, which means we could have factored it. In fact, we did factor it. 2 different ways to solve the same thing. This one, these are real solutions. There's no I. There was no negative radicand, but they are irrational solutions. They have radicals in them, which means we couldn't have factored it. But there's still 2 solutions. And you can still store negative square root of 10 and then test your solution to make sure it's good, to make sure you didn't make a careless mistake. These will both, if you didn't make a careless mistake, these will both be good. You don't have to worry about extraneous solutions with this, what's called the square root property. That's always a good idea to check your answer anyway. Now, in the book, in 12.1, you'll see the formal definition of the square root property. And it goes like this. If you have a number, we'll call it b, and so if b is a real number, and you also have something squared, right? And we're using a for mean some terms, so that would include an x. Something squared is equal to that real number b. Then you can square root both sides and get a is equal to plus or minus the square root of that b. B has to be a real number because you cannot square root an I. You never have an I under a radical sign. Okay? So that's the setup. B has to be a number basically, not an I. And so if you have a squared thing equal to a number, then you can square root both sides and get plus or minus that square root of b. Now that's the algebraic definition of it. Okay? So a little easier to look at on the eyes and put into practice, okay, is this. You've got x squared equal to c. Okay? So I'll make that an x. You've got an x squared on the left.